Hello and welcome to Geometry and Formulas. So before we get started, we want to define a few terms for you to make sure that we're all on the same page on what these mean. The first term that we want to define is perimeter. Perimeter is basically the distance around an object, or the sum of all of the lengths. So perimeter is the distance it takes to go around an object. And that's the outside distance. So here's a couple examples. So here are two examples, and if I ask you to find the perimeter of these objects, perimeter again is just the distance all the way around. So we would simply do, for this first one, 21 plus another 21 plus 40 plus 21 plus 21 plus 40. Adding all those together would then give us our grand total of perimeter. And so we would just simply add those together. 40 and 40 is 80, and then 4 21s. 21 plus 21 is 42, 63, 84.
We have 84 plus 80 is 164.
Now, perimeter is simply a one-dimensional measure because we're just measuring the distance. And so therefore, when we use units to label, we would just say that the answer is yards. The perimeter of this object is 124 yards. Okay, great. What we'd like you to do is pause the video, take out your video notebook, and work on this star-looking object here. This one right here, we'd like you to find the perimeter of this object. Go ahead and give it a try, and then push the play button when you're ready to check your answer. Okay, great. How'd you do? Again, perimeter is just the distance all the way around, so I would just do 2 plus 1.5 plus 1.5 plus 2. So that's this, plus another 2, plus another 1.5, plus another 1.5, plus 2. When we add all those together, let's see, I'm going to add the 2's first. 2, 4, 6, 8, that's 8. And the 1.5s, well, 2 1.5s makes 3, so 3 plus 6. And of course, you could have used your calculator as well. Correct answer here would have been 14. And then how did you label? Ooh, I hope you didn't forget the label. Remember, labeling is really important. We don't want to lose that. The correct answer there would have been 14 meters. So that's how you do perimeter. Now, often when dealing with certain special shapes, for example, a rectangle, we can use formulas to find the perimeter. And I've gone ahead and put this formula sheet up here because these are some of the formulas that we're going to want you to know for our first test. And when it comes to perimeter, we want you to remember that the perimeter of a rectangle is simply 2 times the length plus 2 times the width. Or they have it written there as 2 times the base plus 2 times the height. Either way works. So when dealing with rectangles, remember you can use that formula to help you. Or you can simply do what we just did and add up all the sides. Let's take a look at some rectangles. So I've put 2 rectangles up here on the board. We have one that measures 18 yards and for its length, and then a 5 yards for the width. So if I wanted to use the formula to calculate the perimeter, I could do that simply by doing 2 times the length, which is 18, plus 2 times the width, which is 5, and that's what the perimeter is going to equal. And so when I do that, I get 36 plus 10, which is 46. And again, don't forget the label here. Here, this problem was in yards, so I would say that the answer is in yards. 46 yards to go all the way around. Okay, very good. You try the perimeter of this other rectangle. Feel free to use the formula. We're going to have you do some decimals. You may want to bust out your calculator. You're more than welcome to. Go ahead and pause the video and give this one a try. Okay, how did we do? On this problem, you could have done it, well, of course, a couple different ways, but if you use the formula, you would have done 2 times 12.6 plus 2 times 2.9. You then could have used a calculator if you wanted to. Sometimes it's all right to do that. 2 times 12.6. It may have been easier to do it by hand, actually, but we could also plug it in. So I did 2 times 12.6 plus 2 times 2.9, and the answer comes out to be 31, and you should have labeled that as centimeters. So that's the perimeter of a rectangle. Excellent. The next thing we want to talk about is, since we've got rectangles here, is talk about area of rectangles. So area is a two-dimensional measurement. It's the amount of space, or amount of space inside a closed object. So amount of space. And so for these rectangles, for example, it would be the amount of space. It's two-dimensional. You have to have a two-dimensional object to be able to do this. And because it's two-dimensional, our units will always be reported as units squared because it requires two dimensions. Notice this rectangle has length and width. And the area of a rectangle is simply that. It's to do area equals length times width. So all you have to do is multiply the length and the width. For this first rectangle here, I would have done 18 times 5. You can use a calculator if you want, or do it in your head. Comes out to be 50 plus 40, which is 90 yards. And we would put squared because this is an area measurement. An area measurement. Area is always reported in square units, in this case, square yards. So let's have you do this other rectangle. Go ahead and pause your video and give this rectangle a try. Make sure you do area equals length times width. Good luck. Back already? Good. Area equals length times width. You simply would have done 12.6 centimeters times 2.9 centimeters. When I do that, I'm going to go ahead and use the calculator and do 12.6 times 2.9. Push the enter button. We get 36.54 centimeters squared. Don't forget to label. Labeling's important here. And that's how we do area of a rectangle. Now, let's go take a look in our formulas here because there's some other important ones that we need to know. Notice that here we have this object here is called a parallelogram. And the area of a parallelogram is also area equals base times height. The area of a triangle is 1/2 the base times height. And so those two objects we'll also be testing you on to make sure that you can figure out the area of a parallelogram and also the area of a triangle using those formulas. Okay, so here on the board we have two of these shapes, two parallelograms, and again the area for a parallelogram is just the same as a rectangle. The area equals base times height. The reason that is actually is because if you were to cut this off, take a little chainsaw and go cut that off, and then place it right here, it would actually form just a rectangle, and all we'd have left is a rectangle. So that's why they have the same area formula, which is kind of interesting. So here we would simply do area equals the base, which is 12 meters, times the height, which was 4 meters, and multiply those together to get 48 meters squared. Okay, you give this other parallelogram a try. Use your video notebook just so you can keep working on it, and work on this one. See if you can figure out what the area is. Push the play button when you're ready to resume. Okay, so here you just have to figure out what the base and the height were, because we know the equation is area equals base times height. The base is right here. It's this 8 centimeters, so I write 8 centimeters. And the height, they illustrate with a altitude here with a dotted line going down. That's 9 centimeters. And so we simply do 8 times 9 to get 72 square centimeters. And that's what you should have got for that answer there. So that's how you do area of a parallelogram. It's the same as the area of a rectangle. Okay, the area of a triangle is simply 1/2 base times the height. Sometimes people like to say base times height divided by 2. Both those formulas are the same, so you can do it whichever one you like. That's what we would recommend you to do. When you're doing that, you just need to identify again the base and the height and take that and put it into the formula. So in this one, the base is 12 and the height is h, so area equals 1/2 times the base, which was 12 feet, times the height, which is 8 feet. And so 1/2 times 12 is 6. 6 times 8 is 48. We get 48 square feet. If you're struggling with the math there, you can use your calculator. You could type in 1/2. Remember to use this ABC button, times 12 times 8, and we get 48 square feet. So that's how you do that one. Go ahead and give this next triangle a try and see how you do. Pause the video and push the play button when you're ready to resume. Okay, good. So let's take a look here. On this one, you should have done area equals 1/2 base times height, which would be area equals 1/2 times 11.25 times 15.6. I'm definitely going to bust out a calculator here to help me on this one. I'm going to go 1/2 times 11.25 times 15.6. 1/2 the base times the height, and we get an answer of 87.75. And the units there would be square meters. Again, area is a second dimensional measurement, so we always use square units. Okay, here's a little word problem for you. Let's say that we're roofing our house, and we need to find the amount of shingles that we need to put on the house. In other words, the area of the triangular part here of this roof. And so we're going to leave that to you to go ahead and try, also in your notebook, to find the area in square yards of roof that you need to shingle. Go ahead and pause your video and use the formula to figure out the area there. Push the play button when you're ready to resume. Great! So you should have done area equals 1/2 base times the height. Or you could have done base times height over 2. I'm going to use this second one here since we did it the other way last time. So I'm going to do 4. That's the height. So it's actually the base is 7 times 4, which is the height, divided by 2. 7 times 4 is just 28, and 28 divided by 2 is 14. So we need 14 square yards of shingles to roof our house. We could have also asked you if it costs $5 per square yard, how much would the total cost of roofing this portion of the roof cost? And if that was the case, we would just take 14 square yards times $5, and we would have found out that we're spending $70 to do that portion of the roof. Okay, it's time to talk about circles. Let's talk about circles here, because circles are an interesting object because they're a little harder to measure than some of these straight figures that we've been doing. And so we do need to talk about circles. I have included both the formulas over here. The first is circumference. Circumference of a circle is the same as perimeter, but we call it circumference. So circumference is the distance all the way around, distance around the circle. Whereas the area, well, area formula is right here, and area is the amount inside the circle. So circumference of a circle, the formula is circumference equals 2 pi r, and area of a circle, the formula is pi r squared. Let's bring out some circles and work these out and see what we get here. Okay, so when doing area and circumference of a circle, we have to use a special number. That number you probably heard of. The number is pi. And for a long time, people have tried to figure out what really pi is. We've come to realize now that pi is an irrational number. It's a number that goes on forever. We often just use 3.14, but it does keep going. 1592 dot 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 dot. It goes on forever. It's an irrational number, meaning that it has no pattern and goes on forever. And so we use this number to help us calculate the circumference and area of pi. So if I was going to work with this circle here, circumference equals 2 times pi times r. So I would go 2 times pi times, and the r, the radius of this circle, is the distance from the center to the edge, which would be 4. And so I'm going to go 2 times pi times 4. Now, on your calculators, you should be able to find a pi button, and you're more than welcome to use the pi button, or you can use 3.14 as well. That works as well. My pi button, notice I have to push the yellow button and then this button here to get pi. 2 times pi. You may have to do the same depending on what kind of calculator you have. 2 times pi times 4. I push the enter button and I find out that it's 25.1327, and it keeps going. We'll go ahead and round it to the nearest hundredth, which is 25.13. The units here would be inches because we're doing circumference. Now for area, area would be pi times r squared, which would be pi times the radius. The radius again was 4 squared. And that gets me pi times 4 squared is 4 times 4 is 16. So in my calculator I need to do pi times 16 to get my answer. Again, we'll round to the nearest hundredth, so 50.26, but I'm going to round up because the next number is 5, so 50.27. And my units here, because I'm doing area, would be inches squared. So that's how we do circumference and area of a circle using the number pi. Again, if you want to use 3.14, that's fine. And what we'd like you to do is find the circumference and area of this second circle right here. Go ahead and pause the video and work on finding the circumference and area of both of those circles, of that circle, to make sure you know how to do it. You can hit the play button when you're ready to resume. Okay, great. So in your video notebook, you should have done this problem already. The circumference is 2 pi r. I'm going to need to find the radius of this one. Now, this is interesting because here in this problem, they gave us the diameter all the way across. So for the radius, we're going to need to take and divide this by 2. So 21 divided by 2 is actually 10.5. Our radius is really 10.5. So to find the circumference, I'm going to do 2 times pi times 10.5, and then I'm going to use my calculator to help me out here. I'm going to go 2 times pi times 10.5, and again round it to the nearest hundredth, so 65.97. Sorry, 65.97 feet is my answer for the circumference. How did you do? You may have gotten just a slightly different answer if you would have used 3.14, but we should be really close. The area is pi r squared. I would have taken pi times 10.5 squared. So in my calculator, there's two ways to do 10.5 squared. You could just do 10.5 times 10.5. That would have been a fine way to do it. Or you could find the squared button here. 10.5 squared, and then I times that by pi, and I get that our area answer is 346.36. And you should have used the units of feet squared. How'd you do? Hopefully really well on that. Again, circles, finding area and circumference of circles has been a question that's been long asked, even way before our time. In fact, it's even mentioned in the Bible. Let's take a look at it. So this is interesting. This comes from 1 Kings chapter 7, verse 23. This is talking about Solomon's temple, and I really like this. It has to do with what we're talking about. It says, "And he made a molten sea, 10 cubits from the one brim to the other. It was round all about." So that's interesting. So he made this sea, and you're like, wow, what's this sea? But we'll talk about that here in just a second. What we want to talk about is what would be the circumference of this sea. If we were to go and find the circumference, the distance all the way about, what would you get? Go ahead and pause the video, and this is our last problem that we'll work. Oh, actually, not that's true. Go ahead and work on this in your video notebook, and let's see what you get. Push the play button when you're ready to resume. Okay, great. Hopefully you used the circumference formula. Circumference equals 2 pi r. And hopefully you remembered to take half of the radius. Notice this 10 cubits is a diameter, so they just want 5 here. And so the circumference would be 2 times pi times 5. And if we use our calculator, 2 times pi times 5, we would find out that the distance all the way around is 31.42. The distance around is 31.42. Now that's interesting because in the next verses in the Bible, it talks about the total distance all the way around. Let's take a look at it. So take a look. As we finish the verse, it says that the line all the way around it was 30 cubits to go around it, which is interesting because we got the answer of 31.42. That's crazy. It shows that in the Bible they didn't have the exact measurement of pi. Some people say this is because maybe they just mismeasured. Some people say that maybe it was just because the Hebrews were bad at math, which is kind of funny that the Hebrews were bad at math. But that's interesting that we actually got the more exact answer, and the Bible kind of has a rounded 30 cubits answer. Now, what is this sea that it's talking about? Well, we can keep reading. Take a look. Verse 24, it says, "And under the brim of it round about there were knops," which are like decorations, compassing it, 10 in a cubit, compassing the sea round about. The knops were cast into 2 rows when it was cast. In verse 25, we read, "It stood upon 12 oxen, 3 looking towards the north, 3 looking towards the west, 3 looking toward the south, and 3 looking towards the east. And the sea was set above upon them, and all their hinder parts were inward." So this, we actually learned that this sea here is actually was built in Solomon's temple, but it's the same design that we use in our latter-day temples to build baptismal fonts in the temple, which is kind of interesting. That's cool. So circles, they're all over, and even since the Bible, we've talked about measuring them roundabout, finding the circumference or finding the area. Okay, great. The last type of measurement that we need to talk about today is volume. We want to talk about volume. The volume is the amount of space that needs to be filled. Volume is a 3D or 3-dimensional measurement, and it's the amount to fill. So to be able to do this, you have to have a 3D object, something with 3 dimensions like length, width, and height, and we need to be able to fill it. And when we do this, our units are always going to be reported in units cubed. Cubic units is going to be the goal here. In this lesson, we're only going to talk about rectangular prisms, and the formula is right here. The volume of a rectangular prism is simply length times width times height. So for this example here, we would go volume equals length times width times height. Well, the length is 4, the width is 7, and the height is 3. We would simply multiply those together to get our answer. I'm going to do 7 times 3, that's 21 times 4 is 84 cubic centimeters. Go ahead and do this other one in your notebook, in your video notebook, and let's see what we get, and we'll compare our answers. Press the play button when you're ready to resume. Okay, how'd you do? Hopefully well. We're going to simply use the formula volume equals length times width times height, which would be 5 times 22 times 13. I'm going to go ahead and use my calculator here because the numbers are a little bigger than the way my brain is thinking right now. 5 times 22 times 13 is 1430. And how'd you label that? Hopefully you labeled it as cubic feet. You could have written out cubic feet or simply put feet cubed. Either way works. So the moral of today's story is that these formulas are a great way to find perimeter, area, and volume. And to remember that perimeter is the distance all the way around. It's one-dimensional. Area is the amount inside. It's a two-dimensional measurement. And volume is the amount to fill. It's a three-dimensional measurement. And we use these formulas right here to do so. Okay, well, thank you so much for joining us, and we will see you in the next lesson.